Hi everybody. This is Professor K.S. Ashok Kumar from KIT Kalanjan Institute of Technology from the Department of Management Studies. So today we are going to see about what are the new IT initiatives which are happening in the information management. So right now it is the era of technology. So a lot of new concepts are emerging. Out of those few concepts, we are going to see what is deep learning, what is big data, what is pervasive or ubiquitous computing, what is cloud computing, what is artificial intelligence, Internet of Things or IoT, and blockchain. So these are all the emerging concepts which is going to be the future of IT, information technology, and among that is deep learning. So generally, deep learning is a branch of machine learning, which is completely based on artificial neural networks. As neural networks is going to mimic the human brain, so it depicts what human brain is. So generally, whatever we think, the machine thinks. So it is kind of a exact mapping of your human brain into a technology, so that whatever the human brain thinks or what a human brain will think, the same the machine will also think. So it is kind of innumerable problems arising in the world where a lot of technologies have come. So the problems will also be arising innumerably. So in order to solve all those complex problems, we require deep learning. So you have to go deep into the problem and you have to analyze it. So for that, we use deep learning. So there are three things within a deep learning. One is deep learning, machine learning, and artificial intelligence. So deep learning is where I told you about how you have to go deep into a problem and you have to solve the problem. Whereas machine learning is machine learns how to work autonomously. For example, if a machine wants to work on its own, how to start, how to take inputs, how to convert those input into a finished product, all those things are called as machine learning, which is a farthest step or the lowest step of deep learning. Whereas artificial intelligence is how, for example, if you want to have your AC on in your house before you enter into a house, you will just program a small program in your Google Assistant or your Alexa device, which means the intelligence will tell. For example, if I want to on my AC, if I switch on my lights in my bedroom, etc. All those small intelligence things which will be automatically done for you without you remembering or without you telling the computer to do it. So it will automatically keep in mind. So these are all three things: one deep learning, another machine learning, and artificial intelligence. All three combined together makes the human life easy. So these are all things we have to learn in deep learning. And there are simple deep learning architectures like deep neural network, deep belief network, or deep DBN, or recurrent neural networks. So these are all things which we learn in an advanced stage. For management students, this is basically how technology enables you to take good decisions. So the basic difference between the machine learning and deep learning is machine learning works on small amount of data set, whereas deep learning is about large amount of data sets. And it is dependent on low end machines. So it is, which means if you have a small or an average size computer with a minimum average processor, you can do all those machine learning things. But deep learning requires a very high end system which only developers use. Then it takes less time to train. Machine learning takes very less time to train, whereas deep learning takes a very longer time because it goes deep into a problem and it analyzes it, so it requires more number of time. And how a deep learning is working: so first it understands the problem and checks the feasibility for deep learning. For example, first it will understand whether the problem is too deep to go for a deep learning, or it is simple machine learning kind of thing. So if the problem is eligible to go for a deep learning, it will go for a deep learning, or else it will clearly tell that this particular problem is meant for a simple solution, so there is no need for going for a deep learning. Second one, it identifies relevant data and prepares it. So what are all the data it requires? So it collects from different databases. So it is a culmination of different databases. So it automatically collects the relevant data which is pertinent to that problem. So it collects data from one, database 2, database 5, etc., and it only collects the required information and not all the information. And the third point is choosing deep learning algorithm. So As said, artificial intelligence, machine learning, everything is based on algorithms which we have programmed. So the recurring or the relevant algorithm will choose what type of deep learning to do. And next is training the algorithm. The machine itself will train it to collect the data and how to solve the problems. It will have scenario 1, 2, 3, etc., etc. And at last, after fine tuning all the scenarios, it will create a test model and it will perform the deep learning process, and you will obtain a solution. In many cases, you will get 1 or 2 solutions which will be easy for the manager to exactly take what the problem is and what the solution for the problem is. So this is how deep learning works. And as I said, deep learning goes too deep into it. There are n number of tools used. So Anaconda, Jupyter, PyCharm, etc. All these are certain tools which is used for deep learning. And the languages used are R, Python, MATLAB, CPP, Java, etc. So in case any technology, there are advantages as well as disadvantages. Here, instead of disadvantages, we have certain limitations like learning through observations only and the issues of biasness. So it is purely a machine learned algorithm. So there might be a solution which may not suit you or which may not be applicable exactly to you. So in that cases, there are certain limitations, because even though we are telling that it will mimic your human brain, it will mimic how human brain thinks and all, at last it is a machine. So a machine cannot exactly replicate a human brain, but it will somewhat do what brain can do. So those are certain limitations. And best in class performance reduces need for future engineering, eliminates unnecessary costs. All these are certain advantages of deep learning. And disadvantages is you require innumerous amount of data, because if you want to solve a problem which is high complex, you require data to verify and come to a conclusion. Computationally expensive to train. So you require experts, you require algorithm, you require software, you require machines which are highly costly. And there is no strong theoretical foundation. Everything is algorithm based, everything is software based. So no strong theoretical foundation to prove it. So these are all certain advantages and disadvantages of deep learning. And where you apply deep learning, or the applications of deep learning are automatic text recognition or generation. For example, in Google, today Google has given us, whatever you speak, it automatically translates your language. For example, if you speak in English, it will automatically translate, or it automatically gives each and every sentence in English in any local languages you need. So those are deep learning applications. Then it is used in healthcare. It is used in automatic machine translation. It is used in image recognition. It is used in predicting earthquakes and all. So for all those things, you require innumerable amount of data collected throughout the world. It is not collected in a particular market or a particular country. It is collected throughout the world. So that's why deep learning requires innumerable amount of data. So this is about deep learning and how it impacts the problem solving capabilities of managers. Next, coming to big data. So as I said, deep learning also requires innumerous amount of data. That innumerous amount of data, we generally call it as big data. So a big data is a data that contains greater variety, arriving in increasing volumes and with more velocity. This is also known as 3 V's. So what are the 3 V's? Volume, velocity, and variety. So big data is very essential for computing your deep learning. So in that case, you require volume. Volume in the sense large volumes of data. Very simple example, Twitter uses certain algorithm to predict what are all the correct terms and what are all the non-correct terms. Innumerable amount of tweets will be in a day. So if you want to segregate which are all offensive, which are all non-offensive, which tweet I have to remove, which tweet I have to keep. So all these will be doing in the background, then only it will be reaching the live audience. So before it goes to the live audience, for example, if I am tweeting a comment, before it going to a live audience, the algorithm have to go through all those data. So n number of data, for example, in per day, lakhs and lakhs of tweets would be done. So all those lakhs and lakhs of tweet have to be gone through the algorithm. They have to check whether all these tweets are offensive or non-offensive, whether it will create a problem or not. After that only it will go live. So for those volume of data are there. So that volumes of data will go into deep learning. Then velocity. Velocity is fast rate at which the data is received. in Google Cloud, for example, anybody who's working in Google search, you know that n number of data will be going in a second. So all the data servers will be in such a velocity that it will be receiving petabytes of data. So we are moving from kilobytes to megabytes to terabytes to petabytes, which means the number of data is going to n number of capacity within the database. So that is velocity. Variety means not a single concept or a single idea is being put into Google. For example, if you want to search in Google, I'll be searching in one concept, somebody else will be searching in another concept. Likewise, throughout the world, n number of people will be searching about n number of concepts. So there is variety. So all these three culminated together forms your 3 V's of big data, which is volume, the number of data, velocity, how fast it is being coming and how fast it is going out, variety, how much variety of data which is coming. All three culminated together forms your big data. So what are the characteristics of big data? As I said, the 3 important V's are volume, variety, and velocity. Along with that, veracity, value, variability, exhaustiveness, fine-grained and uniquely lexical values, relational, extensional, and scalability are certain characteristics of big data. So the benefits of big data, or where the big data is being implemented, it is used for thematic coverage, which includes areas that are previously difficult or impossible to measure, where a human form cannot go. All those areas can be measured with the help of big data. Geographical coverage. So for example, if I want to take census population, we require big data. So we have almost 1.3 billion population of if the population of India is 1.3 billion, it is not a small data. There are n number of amount of data is required. So if I have to take a census data, this big data will help me, because n number of geographical areas are there, number of cultural differences. So all these data have to be culminated. There comes volume, velocity, and variety. So this is how big data is being implemented. And timeliness and time series, all these things will be calculated with the help of big data. What are the challenges given in a big data? Representativeness, generalizability, harmonization, and data overload. So these are all challenges given to big data. Now coming to the third important concept in information management is called as pervasive computing, or we call it as ubiquitous computing. In simple terms, microprocessor embedded in any hardware. So for example, nowadays credit cards, debit cards comes with NFC chips, where you need not to physically swipe it and you have to enter your code. Just tap and go, your payment is done. So those kind of concepts, we call it as ubiquitous computing or pervasive computing, which is a growing trend towards embedding microprocessors. So you will see small chips, small microprocessors within a hardware. The word pervasive or ubiquitous means existing everywhere, which means today in this technology, Google Pay, Phone Pay, or whatever technology you have certain communication hardwares, and that communication hardwares have microprocessors. So with the help of microprocessors, the communication happens, whether accepting money or paying money or sending files. All those things helps with the means it is done with the help of certain hardware, which is microprocessor embedded. That concept is called as pervasive computing or ubiquitous computing. Where it is used everywhere: ships, aircraft, cars, bridges, tunnels, machines, refrigerators, door handles, etc., etc. So I can innumerably tell. Today we are living in a smart world. Most preferably, everybody would have a smart home, at least a smart bulb, or at least a smart speaker, where everything is embedded with a microprocessor. You just tell, or you just give a command, everything works automatically. So that concept is called as ubiquitous or pervasive computing. Next, mobile internet access, third generation wireless communication. Nowadays, Wi-Fi is there, broadband Wi-Fi networks. We are moving towards 5G, etc., etc. So which require huge amount of microprocessor equipments in order to attract those kind of data. So these are called as your ubiquitous computing or pervasive computing. So what are the benefits of this ubiquitous or pervasive computing? Is manage information quickly, efficiently, and effortlessly. Smart environment would be embedded with the computing technologies, removes complexity of new technologies, convenient access to relevant information stored. Environment will be supplemented with interconnected digital technology, which means everything is related within digital technologies. whatever communication you have to do, it will be automatically done. Demerits. So as I said in the previous slides itself, if any technology, if it has a plus point, it will also have a minus point. So for ubiquitous or pervasive computing, the demerits or negative points is pervasive computing is not entirely secure because microprocessor can be hacked. Then frequent line connections that are broken. So you need, for example, you are doing simple Bluetooth file transfer. If any kind of hindrance in between these transference, the file transfer will be called off or it will be broke. So those things are hindrances for pervasive or ubiquitous computing. Slow connections. As said, it is purely connected with microprocessors. The data transfer between these microprocessors will be slow, very expensive operating cost. So it comes with external hardware. So microprocessor embedded technology comes with external hardware, excuse me. So it is very, very high cost. So in all these cases, technology will naturally be costly. So once it is accepted and adopted throughout the world, the cost of the technology will come down. So this is the third one, pervasive or ubiquitous computing. The next one, cloud computing, which is very important in today's day-to-day data storing of all the IT companies. Cloud computing plays a very important role. Once when the computer was invented, we used to only save kilobytes of data. We used to have floppy disks, then came CD drives, then came DVDs, then came hard drives, then we have fast hard drives now. After all those things, people started using all these cloud computing softwares like Google Drive, for personal use itself. Individuals are using Google Drive, Google Photos to store all those things. Any hardware which you keep, it may damage. But if you keep it in cloud computing, somewhere it will be stored safely and you can retrieve it whenever you want. And in today's environment, we are speaking about big data, we are speaking about deep learning, innumerable amount of data is required. So it is not feasible for us to keep 1 TB or 2 TB or 10 TB of hard disk. So naturally, people are moving towards paid subscription of these cloud computing. Very good example is people go for subscribing Google Drive or Google Photos for 10 to 20 GB to keep all their memorable photos to be in the cloud computing. So whenever they need, they can retrieve it. So cloud computing is a general term for delivery of hosted service over the internet, which means your data is stored somewhere in the internet and it will be retrieved whenever you require. It enables companies to consume a compute resource such as virtual machine storage on an application as a utility, just like electricity, rather than having built and maintaining computer infrastructures, which means you need not to have a physical infrastructure near you, but your data will be stored safely. That is the concept of cloud computing, where in case of a hardware, you require to take it with you everywhere. You have to keep it safely. You have to be very cautious. If it damages, your data will be lost. Recovering the lost data in a CD drive or in a hard drive is very, very difficult. All those conditions will not be there in the cloud computing. Simply telling, putting all your data instead of a hard drive, you're putting it somewhere over the internet. That is called as cloud computing. So components of cloud: client, data centers, distributor servers. So there would be a client. For example, I'm an individual, I'm a client. I would be storing all my data in any kind of softwares like Amazon Web Services there, Google Services there, IBM's cloud services there. So there are a number of cloud services which are emerging, because day to day the number of data are increasing and the data centers also are increasing. So in that case, more and more companies are moving into cloud computing. So what are the characteristics of cloud computing? On-demand self-service, broad network access, resource pooling, rapid elasticity, and measured services. What are the types of cloud computing? The first important one is SaaS, software as a service, which means whatever we are using, Microsoft Office 365, all those services, we call it as software as a service, which embeds things, or which gives you service when you pay for it. When you stop paying for it, that service stops. So it is not like you own it for your lifetime. Whenever you pay for it, until that it can be used. Any versions, Adobe Photoshop, if you use the paid version, until the paid version is active, you can use it. If the paid version is over, you cannot use it until you have to reactivate the service. Infrastructure as a service. For example, you are lending the infrastructure. Popular examples of infrastructure as a service is IBM Cloud and Microsoft Azure. which give their data centers and their infrastructure to someone else to store all their data. Third one, platform as a service, which means giving individual platforms for all other clients. All these comes under your cloud computing, software as a service, SaaS, infrastructure as a service, and platform as a service. So the different types of cloud services: email, storage, backup and data retrieval, creating and testing apps, analyzing data, audio and video streaming, delivering software on demand. So all these are different types of cloud services which are emerging, and still new adding advantages or adding services would be emerging from this cloud services. So till now we have seen 4 out of 5 or 6 emerging information technology initiatives. All other concepts we will be seeing in the next slide. Thank you all.